Hello everyone. In our last video, we covered the basic calculations for mold design and manufacturing using Python. In this video, we're diving into pure design strategy. We will cover basic core and cavity extraction, multi-cavity plate design, and how to integrate an AI assistant into the workflow. If you're looking for a specific topic, feel free to use the timestamps below to skip ahead. Now, let's dive into our main software, Calclum. It comes fully equipped with all the features you need for parametric and non-parametric 3D design, drafting, and CAM programming features. When you first launch Calclum, you're greeted by this incredibly clean, user-friendly start menu, our gateway to the design workspace. To see Calclum in action, let's bring in a real-world example. Right here, I have a 3D assembly drawing of a plastic puppy toy. While it looks like a simple, fun consumer product, its geometry actually presents some great challenges for manufacturing. Watch closely as we use a series of specialized commands to analyze the parting lines, generate the shut-off surfaces, and completely extract the core and cavity blocks. Calclum automates the heavy lifting here, ensuring perfect drafting angles and seamless splits, even on complex organic shapes like this toy. For this extraction, we're going to focus on the toy's wheel. We'll start by running a draft analysis to determine exactly where our tool will separate. Once we define our pull direction, the software instantly maps out the draft angles. You can see the distinct red and green zones on the screen right now, and that crisp boundary line where the red meets the green is our exact parting line. Now, we simply select that boundary, extract the curve, and just like that, step 1 is complete. Normally, step 2 would involve generating shut-off surfaces to seal any open holes or internal pass-throughs. However, looking closely at this wheel geometry, we don't have any open holes to patch up. Because of that, we can skip right over shut-offs and move straight to generating our parting surface. The great thing about Calclum is its efficiency. The moment we generate the parting surface, the software simultaneously calculates and creates both our core and cavity surfaces in the background. Now, we are just one single click away from the final extraction. Watch what happens when I hit the Extract Core and Cavity button. Instantly, Calclum calculates the ideal dimensions for both the core and cavity blocks automatically. If you need to tweak these boundaries for your specific mold base, the software lets you fully customize and modify these dimensions right here in the panel. Let's hit Accept and see the final result. Beautiful! There it is. The software has cleanly split the tooling. To make it easy to differentiate, the cavity block is rendered here in bright blue, while the core block is shown in green. Now that we have our initial tooling blocks, let's move on to designing the multi-cavity plate for this part. The first step is determining exactly how many cavities we need for production, and how they should be arranged across the mold base. Calclum makes layout planning incredibly flexible by offering multiple automatic placement options. You can arrange your parts in a classic grid formation, a circular layout for balanced runner systems, or even define a completely custom configuration. For this project, we are going to use a standard grid formation. Let's assume our production run requires a 16-cavity layout. I'll input our parameters here and click the multi-cavity layout button. And there you go. In just a split second, the software automatically replicates and positions all 16 cores and cavities precisely to our specifications, giving us a perfectly optimized layout ready for the mold base. With our 16 cores and cavities perfectly arranged, the layout is ready to be integrated into our mold base. To do this, we'll head over to the menu and select Cavity Plate Generation. First, we need to establish our tooling strategy. Are we cutting the cavities directly into the plate, or are we using an insert-based design? To demonstrate a more advanced and complex workflow, we are going to choose the insertable mold option. Next, we define our dimensions. Calclum allows you to pull standard mold bases right from its built-in library, or fully customize the plate size from scratch. For this demo, we'll input our own custom dimensions to perfectly fit our layout. With the parameters set, we just click Generate Cavity Plate, and just like that, the software pockets the plate and seats all 16 inserts precisely into position. Let me quickly hide the core inserts from the view here so you can get a clear, unobstructed look at the cavity plate geometry and the precision pocketing underneath. Now, let's hide the cavities as well, so you can see exactly how the software pocketed the outer surfaces of the inserts. In a real workflow, finalizing your exact insert geometry first ensures the plate perfectly mirrors those precise outer features. Of course, a mold needs more than just a cavity plate, it requires precise filling and ejection features to actually function. Remember those Python calculations from our last video? We've seamlessly integrated that exact logic right into Calclum. The workflow here follows a strict 8-stage wizard. To unlock the next phase, you simply complete the current step, beginning with part and material analysis. Next, you'll choose your layout, whether it's single or multi-cavity, and define the mold structure, such as a traditional 2-plate, 3-plate, or hot runner system. Finally, you'll specify if the product has any complex undercuts. The background algorithm processes all of these inputs instantly, dynamically unlocking the exact design commands you need for the subsequent stages. First, we'll select the cavity plate we just created and feed it into our mold wizard as a reference. Next, we move down to choose our mold type and ejection mechanism. Notice how the software instantly updates this 2D preview below to show exactly how the setup will look. As you browse the various ejection systems and mold types, Calclum's background algorithm is constantly crunching data, giving you real-time estimates for both production cycle times and total manufacturing costs. Next, we'll configure the filling type. When I select our gate point system, we get another live 2D schematic showing the gate layout. From here, we quickly advance through the remaining stages right to the mold library selection. We've integrated a massive array of industry-standard libraries here. All it takes is one final click, and the software automatically generates a fully customized mold base, packed with every specific feature we selected. Of course, we'll still refine the design for final manufacturing. Finally, let's look at the Calclum AI assistant. This built-in assistant lets you generate 3D designs using simple text prompts, or get instant step-by-step guidance if you ever get stuck on a command. Powered by the Gemini and Groq APIs, all you need to do is link your Gmail account to get 2,000 tokens or questions completely free every single day. While daily limits may shift based on platform rules, you always have the option to plug in your own direct API key for uninterrupted access. The interface displays several built-in examples so you can see exactly how it functions. But let's build something fresh. Right now, I'm going to generate an elegant vase in real time. I'll type in a simple 4-word prompt, and the AI immediately lays out the step-by-step logic it will use in the background. Once it finishes thinking, we just click Run in Calclum, and there it is. The software processes the code and instantly builds our 3D model right in the viewport. It's incredible to see what a minimal, 4-word prompt can deliver. Keep in mind, the final geometric complexity depends entirely on how detailed you make your prompts. This stunning 3D model took just a few seconds to generate, a process that would normally take hours of manual modeling. Now let's push the AI a bit further with a more complex example, something that would be incredibly tedious and difficult to model manually. Let's try creating a Möbius strip. I'll just input this 4-word prompt, create a Möbius strip, and hit ask. Just like before, the AI streams the background execution logic, and we just click Run in Calclum. And there it is, a perfectly generated Möbius strip. What makes this topology so mind-bending is that it has only one side and one continuous edge. You could trace your finger along the entire surface and cover both sides without ever lifting your hand. Moving ahead, let's look at what might be the absolute best use case for this AI assistant. To demonstrate, we'll use that exact same wheel part we extracted earlier. But this time, let's look at it from a different perspective. Imagine this project has been handed over to a trainee or a new user who isn't familiar with our specific command layout yet. Instead of digging through documentation, they can simply type their question directly into the prompt box. Look at the response here. The assistant instantly breaks down the step-by-step mold design workflow in a highly detailed format, guiding them all the way from scaling the plastic product up for shrinkage, to the final core and cavity extraction. Adapting to a new, high-end CAD platform is usually a steep learning curve for junior engineers. By integrating this conversational AI directly into the viewport, we make the entire learning process incredibly fluid and dramatically boost team efficiency. That wraps up our look at Calclum's advanced tooling design and its powerful AI integration. If you found this walkthrough helpful, don't forget to hit that like button and subscribe to the channel for more deep dives into smart manufacturing. Drop your thoughts or questions down in the comments below, and I will see you all in the next video.